This is video number 1 on chemical formulas, reactions, and stoichiometry. We will be discussing the last section of Chapter 2, the first section of Chapter 6, and most of Chapter 7 in this PowerPoint. Some of the topics we will be covering include the mole, molar mass and molar conversions, chemical changes/reactions, their equations and reaction type, as well as stoichiometric calculations and percent yield. We will start by studying what a mole is. A mole is a word that represents a number. When you hear the word dozen, you automatically think of 12. If you hear the word gross, you should think of 144. If you hear the word baker's dozen, you may think of 13. There are many words that represent numbers. When you hear the word mole, you need to think of the number 6.02 times 10 to the 23rd. That's how many particles are in one mole. There are different types of particles depending upon what the chemical substance is. If it is an ionic compound, the particle is called a formula unit. If it's a covalent compound, the particle is known as a molecule. And if it's just a single element like carbon, it's known as atoms. Officially, this is defined as the number of carbon atoms in exactly 12 grams of carbon-12. You may also hear this number referred to as Avogadro's number because Amedeo Avogadro was the man that discovered it. We will be using this number as well as some other molar constants to solve mathematical problems. Measuring moles. The atomic mass that is given on the periodic table is equal to the mass of 1 mole of every element. So calcium has a mass of 40.08, according to the periodic table. Something like iron has a mass close to 56. When we want to combine them and actually find the mass of a compound or a molecule, we instead refer to this as molar mass. The units for molar mass are grams per mole, and we'll be using this a lot throughout the semester. There's also something called formula mass, and the formula mass is calculated the exact same way that molar mass is, by summing together all of the elements within a compound, but its unit instead is AMU, or atomic mass units, which we've previously discussed. You are asked to find the molar mass of something. All you have to do is add all the elements' masses together. You're going to be multiplying by their subscript if they have one. Okay, and then you just add them together. So let's do this first example. Calcium, we say, has a mass of 40 from the periodic table, and we have one of them, so we're going to multiply by 1. Carbon has a mass of 12, and we have one of them in this formula. And oxygen has a mass of 16, and the subscript says there are 3, so we multiply by 3. Then 40 times 1 is 40, plus 12, plus 48, the 16 times 3. And when you add all of those together, you should get 100. At this time, it's going to be your turn to try a few of these. What you want to make sure you do, since there are some parentheses, always distribute the number that's outside the parenthesis to each element within the parenthesis when you're solving. So please pause the video and calculate the molar mass of these 3 substances. Please check your answers. If you did not get the correct answer, most likely it's because you did not properly distribute. This 2 should be distributed to the O for a total of 6, and the 2 should also be distributed to the n for a total of 2. The same thing is true here, so 3 times 1 makes 3, and then of course 3 times 4 is going to make 12. And then again, you just add them all together. Now that we've learned how to calculate molar mass, let's actually kind of start to apply it in molar calculations and conversions. We're going to fill out this mole map, which you do not get to use on your test. However, you may find it helpful as we are solving problems. Let's fill out a couple of things here first. Volume is going to always be liters. Particles will be one of 3 things. It's either atoms, molecules, or formula units. Of course, mass is grams, and a mole is a mole. Couple of things before we fill this out. Every time we're going 2 moles, so you're going into the map, you're going to always be dividing. And if we're going away from moles, we're always going to be multiplying. We are going to use dimensional analysis, and we're going to write the conversion factors in on this chart. So if I'm going from mass to moles, I need to use this as my conversion factor. 1 mole divided by the molar mass. That's going to be our abbreviation for molar mass, mm. If I'm going the other way, the conversion factor is flipped. So molar mass over 1 mole. For particles, if I'm going 2 moles, I'm going to be dividing. So it's 1 mole divided by our 6.02 times 10 to the 23rd number that we talked about. If I'm going away from moles, it's the other way around. So my 6.02 times 10 to the 23rd is on top over 1 mole. For volume, this is at STP. We'll spend more time on this in another unit. But for now, when you're going 2 moles, you're going to be dividing by the constant number 22.4 liters. If you're going away from moles, you'll be multiplying. Okay, so you will need to kind of keep this handy as we're going through and solving these mathematical problems, as we'll be referring to it. Let's use these conversion factors. So we're going to start with moles to grams and grams to moles. Okay. It says how many moles are in 45.3 grams of FeCl2. The only time you're going to need molar mass for any of these problems is if it says the word grams or asks you to calculate grams. So I'm going to go ahead and do that here. The molar mass I'll calculate first. 56 plus 35 times 2 equals 126, and I'll be using that. So I'm going to revert back to my normal dimensional analysis. I'm going to take my given and put it over 1. 45.3 grams over 1. And then I need the grams to go away, so I'm going to diagonal drop. And then I'm looking for moles, so mole's going to go on top. And my conversion factor is 1 mole divided by my molar mass of 126 grams. And then I go through and I solve, and I round for proper sig figs. So when you're done, you should get this, 0.0360 moles. Okay. Going the other way, it's very similar. You still need molar mass because it's asking for grams. So I find the molar mass of water. It's 2 plus 16, so it's 18. And then again, I'm going to do my math. So I'm going to put my 8.32 moles over 1. And this time I need to get rid of moles, so it's going to diagonal drop. And my grams will go on top. So just like the other dimensional analysis we've done in the past, this time though you're just going to have to calculate what that conversion factor would be. So in this case I'm going to multiply. And I get 150 point, because I need 3 sig figs, grams. Okay. Next, we're going to discuss moles and particles. This is where we're going to be using the 6.02 times 10 to the 23rd. You'll notice that in these problems, it doesn't say grams at all. It wouldn't matter if you were asked how many moles are in so many atoms of blue goo. You can still solve this problem because we know that 1 mole equals 6.02 times 10 to the 23rd particles. Still going to set up using dimensional analysis, so we're going to start with our given over 1. So 5.42 times 10 to the 22nd atoms over 1. And then again, diagonal drop through dimensional analysis, so atoms is going to go on the bottom, and 1 mole is going to go on top. I'm going to use my 6.02 times 10 to the 23rd. When you plug this into the calculator, you do have to be careful. Make sure that you use proper parentheses or you'll get the wrong answer. And you should end up getting this once you round. If you were instead getting 9.0 times 10 to a very crazy exponent, something to the 40, you definitely missed a parenthesis somewhere in your calculator. Most calculators have a shortcut button for exponents. It's the EE button, or it says EXP. You can use this as well. What you would do to use that button is you would hit 5.42, you'd hit the EE button, and then 22. Then you would divide by 6.02 EE23. You'll notice that in this format, I didn't need to use parentheses. Okay. But whatever works for you to lead to the correct answer. We can also solve a backwards problem here. It says how many molecules are in 9.21 moles of CH4. Let's have you try this, so please pause the video and attempt this problem. This time, because you were looking for molecules, you should have been multiplying. So you would take 9.21 times 6.02 to the 23rd, and you should get 5.54 times 10 to the 24th. A question that I'm usually asked is, do I have to show my work this way? The answer is yes. I know that it's just multiplying and dividing, but it is important that you show your work through proper dimensional analysis. The next type of molar conversion is a moles to liters conversion, or moles to volume, and it's very similar. Instead, you're going to be using 1 mole equals 22.4 liters. So once again, it doesn't matter what the molar mass is because these problems don't have the word moles in them. Please pause the video and try both of these problems. Please check your answers. In the first one, you should have multiplied, and in the second one, you are dividing. The diagonal drop rule still applies. Of course, we can also solve problems where we're converting from grams to particles, or particles to liters, so on and so forth. These are problems that will not have the word moles in them. They are called multi-step conversions, and they really are where the map plays a major role. The general equation for these is this: your given number over 1, and then it's 1 mole over x, and then y over 1 mole. The x and the y are either molar mass, 22.4, or 6.02 times 10 to the 23rd. We'll explore this more in our next video.